So if we look at number 14 on section 1.2, you had problems specifically with C? Did you get A and B? Okay. Let me just quickly go over A and B for anyone else that might be struggling. So it says, consider the function and without graphing, okay? So we could graph this, we could, substitute values, right? I could put a big 4 in front of here and find out what the new graph looks like. But this question is asking you, saying, without graphing, see if you can figure out sort of what happens. Now, you want to think about the mapping a little bit. You want to think about what we learned about the mapping and stuff. But right now, this is, this is a parabola. Okay. From your previous work, you know that this parabola opens upward. Okay. Nod your head if you understand that. We're going to talk more about why this opens upward. Okay. And you already actually know, but it's the A value. Remember, last year you learned about vertex graphing form, and if this number in front was a negative, it opened downward. Okay. That's a reflection about the x-axis there. You see that? Open up, open down. So you already know that this opens up. Okay. What else do you know about this statement right here? What does the 4 and the 3 have to do with the graph? Yeah? Okay. It's in factored form. Yeah, it's not in intercept form. Not necessarily intercept form, but yes, you can see the intercepts here from the factors of the quadratic, yes. And so x plus 4, if I let this factor equal 0, I have an x value of negative 4, which means that's going to be an x-intercept. And at positive 3, we're going to have another x-intercept. So we're not going to graph it, but we're going to consider, and this is what you're thinking in your brain, okay, I'm not going to graph it, but this is what you're thinking, at negative 4 and at positive 3, we have zeros, and we know it opens upward. So you're thinking this in your brain, you're not actually graphing it, but it looks something like this, right? Okay, this is what you're thinking. So what happens to the zeros of the function, and that's the intercepts here, negative 4 and 3, when this is applied? Okay. Now, I think I showed you in the lesson yesterday with Desmos there how this moved. I'm not sure if I did or not. I will show you after this to confirm. But if we have a graph, all right, that stretches down and it crosses the x-axis like this, okay, you have to consider how this transformation works. Remember, this is 4 times all of the y values for the graph. So the easy way to think about this is the zeros are where y equals 0. Okay? Negative 4 is the x value, 0 is the y value. 3 is the x value, 0 is the y value. So if we're taking all of the y values for this graph that we haven't graphed, okay, we don't see this, but we're taking all the y values and we're multiplying them by 4. So for the zeros of the function, that's y equals 0, and then we times 4. So what happens? Nothing, right? 4 times 0 is the same as 0. So determine the zeros after this transformation in A. The zeros are exactly the same as the original function. Okay, so the zeros are x equals negative 4 and positive 3. The same. B, okay, when this negative x here, okay, so that represents a flip about the y-axis, right? Right? So without graphing, what we're going to do is we're going to change all of the x values on all the points. So the zeros are negative 4, 0. That's going to change to positive 4, 0. The positive 3, 0 is going to change to negative 3, 0. Okay? So I'll just write that down here real quick. But we have the zeros negative 4 and 0 and 3, 0. So with this transformation right here, we flip the sign of all the x values. So these are your new zeros. And again, envisioning this in your head, if you flip this about the y-axis, here would be like the vertex on this side. So it's going to be flipped and it's going to be like this. Right? So that's how those zeros change. Negative 3 now and positive 4. Okay, C. Get to C. That's what you actually asked about. So C. Every x value is going to be multiplied by, thank you, 2. 1 over b, and b here is 1/2. So we take each x value of the original, here's the originals, right? And we multiply them by 2. So this represents a horizontal stretch, okay? The graph that we haven't drawn, we know is going to stretch like this, you see? It's going to be flattened out. It's going to be pulled apart horizontally. So it would make sense that each x value is going to be multiplied by 2. Because that would make sense here in our brain to go to -8. That totally makes sense. This one to +6, that totally makes sense. Right? So you're thinking mapping notation here. And this one here, 1 over bx is how the new x values are going to be. So each of these original x values are going to be divided by 2. Like that. So that would make sense from this one here. If we did it in red. Each of these would be divided by 2. The 3 goes to 1/2. Okay? And all these x values. So it kind of looks like this. Does that make sense? And there's, okay? All right, and let's just confirm that here. I have this one up here somewhere. Where is it now? Yeah, way down here, okay? So here it is right here. And let me just kind of move that around a little bit. Okay, so this z here, don't ask why it's z. It wouldn't let me put a there, so I don't know. But it let me do z over here. So this is like our a value outside the function, right? Just like a, number a, letter a. So it goes like this. If I change this from 1 to make it 4, look what happens. Okay, the zeros are not changing, right? But it does, everything else stretches. But 0 times 4 is still 0. Yeah. Yes. Go back to the question. Yep. Yes. Yep. Yeah. You can multiply each x value, and then so you're saying half each x value, and then solve, and then put those values in here. That's what you're saying. Yeah. So I would just stick with the mapping notation because I don't think that your suggestion there is going to work. So just think about this: that the mapping notation where x and y is, whatever b is, and here in this case b equals 1/2. So the new mapping notation is 1 over b, comma y. So that'd be 1 over 1/2 or 2x. That's what you want to do. Sorry, 1 over bx. Okay, good question. So that's number 14 there, how to kind of apply these changes to zeros. All right, I do want to go over one thing with you. And I want to talk about this. Let's cut that. Let's bring it down here.